Okay, welcome to the notes on proving triangle similarity. Alright, so we have some vocabulary to start with. These are things that come up in proofs, and you're going to have to know their symbols and remember what they mean. So remember two parallel lines were two lines that never crossed. And if in a proof you're trying to say two lines are parallel, you use this symbol. It's two parallel lines running up and down just like that. Okay, and you're going to use this mainly if you're trying to say two angles are the same because of alternate interior angles. Because before you can say two lines are alternate interior, you have to say that, or two angles are alternate interior, you have to say that the two lines are parallel for that to work. So, you're going to need that. Perpendicular lines are two lines that cross like this. So, there's a line here and a line here. And they're crossing so perfectly that on either side, you have a 90-degree angle. So right there you have a 90-degree angle, and right there you have a 90-degree angle. And it's kind of like a perfect cross, okay? And the reason why you'll want to use perpendicular is because it lets you say that you have two 90-degree angles if you do in the picture. So, two perpendicular lines are two lines that cross at 90-degree angles. Okay? Then you have midpoint. And a midpoint is the point that cuts a line directly in half. So if you have a line, let's say the whole thing is like 10, the midpoint would be right in the middle, making each half 5. And in proofs of triangle similarity or congruence, this comes up because it will let the two lines be the same length. If it's a midpoint, it's because it's directly in the middle. So from the last lesson, you should remember that we have 3 conditions that prove similarity. One would be angle, angle, and then side, side, side. And remember, all those sides are not the same, but they're being multiplied by a scale factor that's the same. And then there's side, angle, side, where the sides are being multiplied by scale factors, but the angles are the same. So, for this guy, they're asking us, are these two triangles similar? And we got to figure it out. And so, do we have angle, angle? Well, I know one angle is the same, but I don't for sure know the other angles that are, because this one only gives me 1. And this one gives me 2, but I don't know about the second one. For my sides, I can check though, because I have an angle, so I could have side, angle, side, because that's one of my 3. So this side is 8.4, and I think that aligns with 4.2 based on the way the picture looks, right? And if I don't know, I could check both. But if it is 4.2, to figure it out, I would do 4.2 divided by 8.4 in my calculator. And I'd get 0.5, meaning to go from here to here, I have to times by 0.5. So then I'm going to check it with my other one. So 16.4 I think is the one that goes with this one. So if I thought it was 12.3, I could check. I could do 12.3 times the 0.5, and I would get 6.15, and that doesn't look like it to me. Okay? So then I'm going to do 16.4 times that 0.5, and look, I do get the 8.2. So from here to here, when I times by 0.5, I get the 8.2. So I know those two are the sides that correspond to each other. So do I have enough now to prove they're the same? Well, I have this side that's the same, then by when I times by 0.5. At this angle that's the same, and this side that's the same also when I multiply by 0.5. So now I'm going to prove my two triangles are the same because I have enough information because I have SAS. So I'm going to prove my two triangles are similar, not the same, but similar. Okay. So first I'm going to start with the side. So I can say side UR times the scale factor equals, so side UR times our scale factor equaled over here. Side A is the one that goes with U because it's the one that would be 103, because R is the one that's 47, like C. So it's going to be AC. Okay. And so beneath the letters, I'm going to write the math so I can see it and remember. So UR was 8.4. My scale factor was 0.5, which got me 4.2. We did this because of the scale factor. Okay, so now I have a side. That's a scale factor. Then I do my angle, and its angle URN was congruent to the exact same as angle ACT. And I know that because it's given. They're both 47. And then finally, I have my next side, and that's RN. So side RN, which happened to be 16.4, so I'm going to write that beneath it, times the scale factor, which was 0.5, so I'm going to write that beneath it, was equal to side CT, is what goes with R and then N. So CT. And CT was 8.2. I'm going to circle that, and I knew that was working out because of the scale factor. So now that I have all three of these, I can say that triangle URN is similar, remember we're proving similarity, so use the similar sign, to triangle ACT. And I was able to prove this because of side, angle, side. So at the bottom, it says determine all the missing side length and angles measurements of cat and run, which were the two triangles. And so, in order to do that, right here, remember U went with A, so U is also 103. Remember that a triangle has to add to 180. So if I do 180 minus the 47 minus the 103, I'd find the last one's 30. And that's true for both triangles. And finally, the last side I don't know is this 12.3 goes here. And to do that, I have to times it by 0.5. So 12.3 times 0.5 is 6.15. And that's that last side right there.